In this paper, we propose a novel data-driven framework to synthesize realistic finger movements for dexterous hand manipulation. Given the 60 trajectories of the wrists in the object, our system synthesizes the detailed finger motions for manipulating the object. Our system runs at a frame rate of 60 frames per second with fixed latency, thus can potentially be applied for real-time applications. To accomplish this task, we propose an architecture that we call ManipNet. It is a time series model that predicts the hand pose from control signals, which include the previous pose, wrist and object trajectories, and virtual sensor inputs. The network is specialized for controlling the right hand. For controlling the left hand, the pose and the object are mirrored and fed into the network, and then mirrored back. By running the network twice per frame, we can synthesize two-hand object manipulation. To train our model, we captured motions where the hand manipulates various primitive objects and kitchenware. To increase the generalizability of the training data, we use input features based on the spatial relations of the hand and the object. More specifically, we use sign distance sensors, which senses the shortest distance between finger joints and the object's surface, as well as the normals on the object at the closest points. We also use the proximity sensor that casts rays in the normal directions of the hand and finger surface, and senses the distance between the origins of the rays and the point they intersect the object's surface. Finally, we use a volumetric ambient sensor centered near the palm that detects which voxels are occupied by the object. Here are some of the results of randomly manipulating primitive objects. Here is an example where the same input is applied to two different shapes. It can be observed that the fingers are adapting well to the object geometries. We can also scale the objects to different sizes. Note, we do not do any data augmentation during training. Here are some results of manipulating kitchenware. Note that for the teapot, this model is different from the model used for training. Even with a geometry not seen during training, the system can adapt the hand pose to manipulate the object. Our system can be used to control the left and right hand independently to hold two different objects and accomplish a task. Here are the ablation studies of removing different components from our model. Here is an interactive demo where the animation is synthesized while the user is manipulating a template model. Note that the finger motions are not tracked but synthesized by the system on the fly. Note that neither the real object nor the virtual objects are used for training. Thank you for watching.